Hi everybody, this is Mrs. Dunn. We're going to be talking about functions and graphs today. Specifically, what we're going to do is identify a function, identify the domain and the range of a function, evaluate a function, and graph it. Okay, so let's get started. So the first thing we need to do is to establish what exactly is a function. So the definition of a function is a function is a correspondence between a first set, called the domain, and a second set, which is called the range, such that each element of the domain corresponds to only one element of the range. I know that's a lot to digest, so let's look at this with a couple examples. So in the first example, we have the set M, N, R, and S, which is going to be assigned to the set A, B, C, and D. So you're looking to see, is every element of M, N, R, and S, that first set, assigned to only one element in the second set? And the answer is no, it is not. So this is not an example of a function. So, and the reason is because for the letter M, it's assigned to both A and B in the second set. So this is not a function. It violates this part of the definition. Okay, let's look at another example. So in this example, we have A, B, C, and D that are assigned to R, S, and T. So think about this. Do you think this represents a function? Did you say yes? I hope so, because it is a function. Every element of the first set is assigned to only one element in the second set. So basically what you're looking for is you look at this first set and see if there's any element that has two arrows coming from it. And if there are two arrows that are going to different values, then that is not a function. Here, every element in the first set has only one arrow coming from it. So that's how we can identify that it is a function. Okay, so now let's talk about domain and range. So this one is not a function, so we're not going to talk about this one. But in this function, what would be the domain and what would be the range? The domain, remember, is the first set. So the domain is on the left. It would be A, B, C, and D. And the range is the second set. So it would be R, S, and T. Okay, so now let's look at some examples in a different format. So what if we are given a set of ordered pairs? Does this represent a function? Remember, the definition is still right here. So think about this. Is every element of the domain assigned to one element in the range? And the answer is no, it is not a function. Once again, it violates that condition because -2 is assigned to 1 in this ordered pair and assigned to 4, a different value, in the second ordered pair. So that is not a function. What about this relation? And yes, this one is a function because every element is assigned to, of the domain, is assigned to one element in the range. So what is the domain and the range of this function? The domain is the x values and the range is the y values. So in this example, the domain is -1, -2, -4, and 0. The range is just 3 and 7. Here's another way to look at it. Let's look at these graphs. You might have learned this in a previous class, but what we do is what's called a vertical line test. And you can see that drawn here. So in the vertical line test, to make sure that every element in the domain corresponds to only one element of the range, you're looking to see if a vertical line goes through a function more than one time. So you can see if I draw a vertical line, I can't draw one that's going to cross this more than once. But here's a vertical line that actually goes through the function 3 times. Here's a vertical line that goes through the function twice, and here twice. I can't draw a vertical line that goes through this more than once, and I can't do it here either. See, this closed dot means it's included, and this open dot means that it's not included. So those pictures, relations that are not functions are B, C, and D, because they don't pass that vertical line test. Okay, hope that makes sense. So moving on, the next thing we want to do is talk about function notation. So this function notation is read f of x. It does not mean f times x. It means f of x, or the value of the function f at x. Let's look at a couple examples of this. So for example, we have f of x is equal to 2x squared minus x plus 3. We can evaluate the value of the function f at the value 0. So when x is 0, what's the value of the function? That simply means plug 0 into this equation. So if I plug 0 into there, I get 3. This term is 0, this term is 0, plus 3 is 3. Now you try one. So the value, find the value of the function at -3. Pause the video if you want and work it out. Did you get 24? So remember, you're going to plug -3 in for x. I always use parentheses when I'm doing my substitution, so you don't make any mistakes when you plug it in your calculator or work it out. -3 squared is a positive 9. Check to make sure that you got that. And 18 plus 3 is 24. All right, the last thing I want to do is go through these functions. I want to show you how to graph these on your calculator, and I want to show you a couple of features on your calculator that can help you. Okay, so first of all, going in order, we're going to graph f of x is equal to the square root of x plus 4. So remember from the last video, if we're going to graph this, we have to press this y equals button. And we want to graph the square root of x plus 4. So I need to access the square root button. So I'm going to press second in square root. And then I'm going to type x plus 4 inside the radical. In the newer calculators, we're going to use the arrow button to toggle out of there. Remember to make sure that you're in the standard window. So I know that I am going to, but I'm going to press graph, and you can see that I'm in the standard window. And here's what the graph of f of x equals x plus 4 looks like. Okay, I want to show you how to find a function value on the calculator. So if we want to find the value of the function using the calculator, you're going to use this calc menu. So press second in calc, and we're going to find a function value. So for example, if I want to find the value of the function at 0, I'll plug 0 in and press enter, and you see that the function value is equal to 2. So we can see that we got from the calculator that f of 0 is equal to 2. And look at what happens if you did it by hand. If you did it without the calculator, see how algebraically you're going to get the same answer. When I plug in 0, the square root of 0 plus 4 is the square root of 4, which is equal to 2. Okay, so let's look at the next. The next thing I wanted to talk about was domain and range. So looking at the graph of the function, what is the domain of the function? Well, the domain, remember, is the x value. So it looks like this graph starts at -4 and goes to infinity. So notice I'm using a bracket on -4 because -4 is part of the domain. We use a parenthesis anytime we use infinity. So the domain goes, we can use any x value from -4 until infinity. And the range, the y values, are going to start at 0. It goes through that point and goes to infinity. You can see that on your table as well if you'd like. So if you look at your table, notice you get an error message at -5. And why would we get an error message at -5? Well, that's because -5 plus 4 is -1, and you can't take the square root of -1. All right, so let's look at the next example. So our next example is x to the 4th minus 2x squared minus 3. So we're going to graph that. I'll clear the last one out. So we're going to type x, and if I want to the 4th, I use this caret button, x to the 4th. Whoops. I have to use the arrow to get out of the exponent. So x to the 4th minus 2x squared minus 3. And let's look at this graph. So this time I want you to talk about what's the domain and the range of this function. So what would be the domain? What are the x values that are allowed? Well, the x values that are allowed are -infinity to infinity. So the domain is basically all real numbers. Now, what about the range? You can see that the range starts at -4 and goes to infinity, and we're including -4. So we use a bracket to include -4. All right, next example. F of x is equal to 1 over x minus 4. You have to use parentheses on the bottom here. If you forget to use parentheses, you're not going to get the right answer. So x minus 4 in parentheses. And let's look at this graph. So this is a rational function. We're going to be studying these in more detail all semester. But notice here, this is a funny graph. Notice it doesn't go through +4. Now, why would that be? Because a +4 is going to make the denominator 0. And remember, we can't divide by 0. So what's the domain and the range of this function? Well, the domain of this function goes from -infinity until we get to 4, not including 4, which is why we have parentheses. And then it starts back up at 4 and goes to infinity. So we use this union symbol to join these two intervals together. And notice there's a parenthesis here because 4 is not included. We can't plug 4 into this equation. Remember, we'll get an error message. You can see that on your calculator. If we plug in 4, we get an error message. Okay, so what about the range? So it also goes from -infinity to 0, because it has a gap here at 0, and then 0 to infinity. So just like the domain, it's in two pieces. Notice parentheses everywhere. Okay, next example, and our last example, is an absolute value equation. So I wanted to show you how to find absolute value on your calculator. So to find the absolute value key on your calculator, you have to type the math button and then use the arrow to toggle over to the NUM menu. And ABS stands for absolute value. Now on the newer calculators, you're going to actually see these absolute value symbols. And you're going to type 3x minus 2 in the absolute value symbols. Use the arrow button to get out of there, and then you can look at the graph. And the domain and the range of this function. The domain of this function goes from -infinity to infinity, and the range goes from 0 to infinity. And notice that we're including 0. Okay, that's all there is to it. Good luck. Email me with any questions.